Now, in this short video, I will tell you what happens to the electric field, the net electric field inside an insulator when you bring a charged object around it. So, let's say we have this the red rod, and it has a charge on it on the surface, and this is an insulator. It is neutral, and well, I know insulators do not possess any electrons mobile to move anywhere around the object. All electrons need to stay near their nuclei. So what will happen in this case? I will end up having a large number of microscopic dipoles. And these electrons, the electrons that are pushed away from the excess charges on the rod, these need to be around their nuclei. Now, I have mentioned for a conductor, the net electric field inside the conductor will go to zero if you wait for a little bit of time, as a result of polarization. Now, in contrast, when you have an insulator, so let's draw the electric field. So the electric field from the rod, let's say it is this one. This is the electric field that the rod creates at the center of my insulator. Now, once the polarization process stops, the net electric field inside the rod will be smaller, but it will not be zero. So this is E net once polarization stops. And we do know experimentally E net, the net electric field inside will be a fraction of the one created from the external object, like the rod in this case. And this denominator is what we call the dielectric constant. And this depends on the material, the kind of insulating material that you have. Now, in conductors, I said the net electric field will become zero. In insulators, that is not the case. The polarization of insulators will decrease the net electric field that you get inside the insulating object, but it cannot bring it exactly down to zero. And it will decrease it by an amount that depends on the polarization, that depends on the material that you have, the kind of atoms that you have, and how easily you can polarize them. And this quantity that shows us to what extent the net electric field inside is decreased we call this constant the dielectric constant.